Hello, it's Chelsea Moose. Hey everyone. We're gonna talk real quick about rational expressions. So I hope you're ready with your notebook and a writing utensil. So for those of you who have your book at home, I also need to post it, don't I? This is our white book and it's page 14. So you're supposed to do this in class, obviously, but what is life anymore? And this you would do with a neighbor, a friend, a foe. I'm not sure. So the problems line up. They're different, but they simplify to the same expression. And so for the directions, it says you and your partner will work together to complete these rational expression problems. And you're supposed to check if they don't match, then something's wrong. And it says simplify. So we're not solving, we're simplifying. And list domain restriction. List any. Sometimes there's not any, but usually there is if we're dealing with x in the denominator. Domain restrictions. Okay, cool. So remember that domain is x. Okay, so we're going to go through this. I'm going to start with the left-hand column, and then we'll sort of from there jump to multiplication. And then you'll see later in the book that it also does division. Division is not as complicated for these expressions as it was for polynomials. I'm only going to say that once. Okay. I'm a monster. So this is 1, and it's like the left-hand side. So I'm going to copy it down from the book. I'll post the book again, just so there's a PDF version. Your fraction bar, your vinculum, has to cover everything, remember? Okay, cool. So we're just simplifying here. Simplify. And you're like, well, everything is fine. I don't see what else to do. I swear to someone's llama, if you do this, I am going to lose it. So it's a good idea. We see what you're trying to do. No, don't do that. Okay, cool. So the numerator is up top. Numerator. And the denominator is down below. Denominator. So the numerator is simplified. So this is already simplified. Simplified. That's an F. Whatever. So the denominator, I guess I don't actually want that. Sorry. Oh my gosh. So that's already... Oh my gosh. Okay. Listen, I'm new to this. This is already simplified, so now I need to simplify this. So need this. So I want you to focus your attention on this denominator. Okay. Greatest common factor. Side note with a star. So in 7x and in 35, there lives a number. Yep, it's 7. So we are going to factor out a 7. So I'm going to go back through with green. Here's my arrow. So I leave the numerator. I'm going to factor out a 7. So here, I'm going to write that factor out 7. That's what we did. Okay. So a number divided by itself, so 3 divided by 3 equals 1. It's true. X squared divided by x squared equals 1. So I am going to use my highlighter now. So x, this quantity here, x minus 5, divided by x minus 5, is the number 1. Oh my gosh. Sick. All right. So there's going to be something that you are going to forget, and it's fine. I'm not mad about it. I am, in fact, it's like expecting it. So now it's almost like I don't have a numerator, but I do. I have a 1. So this simplifies to 1/7. I know, it's crazy. Here's what I have to say. I have to say that x cannot equal 5. If x equals 5, then 5 take away 5. So this is my domain restriction. Oops. Domain restriction. X cannot equal 5. Because 5 minus 5 equals 0. We can't divide by 0. Can't divide by 0. Well, you get the idea. Schwetz, huh? Okay, so this is our final answer. So I'm going to write down here. Ooh, let's do red. So x minus 5 divided by 7x minus 35 simplifies to 1/7 with the notion that x cannot equal 5. So if you leave this off, it's not too horrible, but this is like a package deal. Cool. So that was the first problem. And then the other number 1, so x plus 3, that one, if you have your book, is similar, except for the domain restriction is a little bit different. All right, new page, y'all. Numero dos. I made custom colors. I'm just wondering where they went. And I know you don't care, so I'm going to move on. But I'm sad about it. Okay, so number 2. And again, this is page number 14 for those of us who have the book in front of us or nearby. Numero deux. Okay, so I have, oh gosh, look what's happening. X squared minus 2x minus 15, oh boy, divided by x minus 5. Here's the deal. We have a short unit and I like you. So I'm going to tell you a pro tip over here. Pro tip. Look. I wish I could like insert googly eyes. I'm not that good yet. Look at denominator. And try. It's not always possible to match. What do I mean? I mean match factors. So if I am thinking about like this, and I know that I'm able to like cross stuff out, I want to look for that in my factoring of whatever I'm doing. So numerator or denominator, doesn't matter which. The other thing, excuse me. The other thing is that sometimes nothing will cancel. Just heads up. Okay. So this, so like other thing to star, so like denominator, oops, is already simplified. I'll write that out. So like need to factor numerator. Okay, so I need this, yeah? So you have to factor this, so you can use box and diamond, right? Diamond, whatever works. Or I like the one that has like the circle in it. It's the same thing, honestly. It really is. Okay, so I'm going to rewrite this. 2x minus 15. So I'm going to use this model. So I know that x squared goes here. I know that negative 2x goes here, and I know that negative 15 goes here. Factors of 15 are 1 and 15, 3 and 5. I have 2, so I'm thinking it's probably 3 and 5. It's negative, so I'm thinking that this is a negative 5. So I'm going to force that to be negative 5. This is going to be positive 3. I forgot my x's. Oakley, Dokily. 3x, because x times 3, area model, x times -5x. So, remember, or wait, I don't want that. I want to, like these are what combine here. So, -5x plus 3x does equal -2x, so that's true. Okay, cool. I'm going to use a highlighter. Am I going to use a highlighter? Yes, I am. So this top of my box and this other side. So these are my factors. Factors. Okay, so now we're going to rewrite. Oh no. Oh no, we don't want that. We want the pen. So we're going to rewrite. So much fun. It's just like some magical footwork, you know? That's all math really is in the end. X plus 3. I'm a little bit worried because my freshmen right now, they're going to miss a lot of their factoring, and I'm worried about them. But you know what? They'll be fine. Okay, cool. So now we can simplify. It's almost like you have to unsimplify and then like re-simplify. So I'm looking for things I can cross out or off. So look for, we used to call it a giant one. I'm going to say that because I think it's still true. It's like we would do this when I taught 8th grade. So my giant one is x minus 5 divided by x minus 5. Ha ha ha. It's right here. Bye-bye. So my final simplification is this. If you said that and you didn't say the other thing about the -5 like issue, you'd lose like 1 out of 4 points. It's not the end of the world, but it does have an impact, and we'll see that later for graphing. So from here, you need to say something like, however, x cannot be +5. So this is our final answer. Final. Sick. I know, it's amazing. I'm wondering if, no, you don't care. I'm going to add a new page, but when it adds a new page, I'm noticing that it adds a new recording. So let's just keep doing that and we'll be fine. Okay. Last one. Hi, how are you? So this is page 15. Oh my gosh. And it's number 3. So let's actually save. Well, I'm going to make multiplication a different video. It's fine. Everything is fine. Okay, so I'm going to do, oh, I didn't do my example yet. Oh gosh, what could go wrong? Nothing. Have some faith. Okay, so I have a quadratic divided by another quadratic. Having flashbacks to polynomials. 20. Let me make sure I wrote that down. X squared, take away x, take away 12, divided by the quantity x squared, take away 9x plus 20. Okay, cool. So I'm going to say both need to be factored before is so important, before creating your giant ones. Whatever. Okay, so alert. No. You can't. Oh my gosh, I don't even want to write it. It hurts so bad. It hurts my soul. And I know Miss Crow has like stuff on her door sometimes about this, which is funny, but you know, math teachers. You can't do this. Oh my god, please don't do this. I swear it's like a puppy loses a toenail or something. So what would that be if you combine those? 11? No. Oh my gosh. Can I make a circle? I can. I can do anything. Oh. Well, you get the idea.
Judy?
Don't do that. What?
Did you open that Pinot Grigio?
No.
Where is it?
It's in the fridge. Okay. Well, I don't know if you heard that, but that was my husband. Sorry. Okay, so you can't do that. Don't do that. I don't want this circle where it is. I don't want it. I don't want it. I don't want it. Okay, I'm going to do this, and I'm going to do this, and I'm going to do that. Okay, so moving on. So from here, I'm going to do my numerator first. So I'm going to factor this. So I know that negative 12, negative x, x squared. So this is x, this is x. I know that this has 3 and 4, and it combines to be 1, so I'm going to use that. Maybe I'll make that green. Okay, so minus 4 plus 3. So now, here's my highlighter. Here is my numerator. Okay, so the other thing that I want to do is factor the denominator. And usually these are nice to factor, so you're not going to really run into any like quadratic formula situations, because that would be cruel and also unusual. And you know what? We don't have time for that anymore, so stay calm. Okay, x. What am I thinking? 2 and 10. Nope, because that's 9. 4 and 5. Let's go. Still got it. I want that to be green. You know what? It's okay. They're both negative. This is positive. So negative 4, negative 5, because, right, negative times negative is positive. Let's go. I'm going to use yellow. So here and here. Okay. Chouette. Je peux le faire. Hein? Okay, so I'm going to use red because my numerator is red. Numerator. So, I have x minus 4. You need your Huggy boys. And then my denominator. It's like, why do they have to be such long names, you know? Is, let's make this vinaigrette neutral color, is, I'm even going to put them right on top of each other. Look at that. What a convenience. Sick. All right, so you're going to cross off what makes a giant 1. So x take away 4, divided by x take away 4. No matter what x is, this is 1. Bye-bye. I really miss saying that. So our final statement is this expression. This is okay. We have to remember to say that x cannot be 4. It can't be positive 4. So sometimes you'll have a fraction as your solution, and that's fine because you've only just like sort of manipulated this thing that already exists. We're not always going for like a whole number, right? We're not finding a solution to anything. We're just like kind of like creating a situation where it is maybe easier to work with, probably, yeah. But that being said, within this domain restriction exists an impossibility. I know, it's crazy. Okay, that's enough for right now. So I'm gonna give you more practice problems later this week. And I'm going to pull from this page. So I'm going to pull the other 3 because it's the same. So please reference these notes as needed. You are amazing. And I just miss you so much. Okay, bye.